Okay, in the last lesson we said that Rutherford discovered that an atom is made up of a tiny nucleus in its center that contains neutrons and protons, and then surrounding that it has electrons in shells. Okay, now we're going to look at the separate properties of each of those constituents. Okay, so we have the neutrons and protons and our electrons. So first thing we're going to look at for each of them is their mass. Now, if we were trying to measure the mass of a proton in kilograms, we're going to have a zero with more than 20 zeros after decimal place before we start getting numbers. It just doesn't make sense to measure something that small in kilograms. So instead we just say the proton has a mass of 1 and we compare everything to a proton. So we call this method of measuring things relative atomic mass, and what we find out is neutron has roughly the same mass as a proton, therefore we count it as being 1. Meanwhile the electron is much lighter, about 1/1840th of the mass of a proton. What we find out is that protons have charge. Once again, if we used coulombs that we usually use for measuring charge, for a proton it'd be a very, very small amount. Therefore we just do the same thing. We say proton has a charge of +1 and we measure everything relative to the charge of a proton. Neutrons are neutral, meanwhile electrons are negatives but have the same charge as a proton, but just in the opposite direction really. So think about it as being positive protons, neutral neutrons, don't think negative, it's neutral neutrons, and then our negative electrons. And then our location, the protons are in the nucleus, the neutrons are in the nucleus, meanwhile the electrons are in the shells surrounding the nucleus. Be very, very careful, because quite often in exams they've asked questions like how many of these things are in the nucleus, and people don't read that last word. They just see it as being the atom and they start talking about how many electrons are in the atom. Meanwhile, there might be lots of electrons in the atoms, but there would be none in the nucleus because the electrons don't exist there.